Hello, everyone. This is Carolyn Chapel, and today I'm going to talk about conditional probability and tree diagrams. And I'm going to do just one example here, but we will calculate quite a few different probabilities using this tree. And I will do another example in a later video. So please think of our example here that we have. We have a box, and it contains 7 purple and 3 green balls. So a total of 10 balls are in this box or bag or whatever container you want to have them in. 7 of them are purple, 3 of them are green. And what we're going to do is we're going to take 2 balls out of this box, one at a time without replacement. Okay, and I'm going to use a tree or draw a tree to kind of describe this experiment. So when drawing a tree, you want to think of yourself physically doing this procedure. So here you are. So there I am, this dot. Okay, and I'm going to go into my box and I'm going to draw a ball. Now, granted, there are 10 different balls, so I could draw 10 different branches. But what we're concerned about is the color of this ball. Okay, and basically then there's only 2 possibilities. There is a purple possibility, or we could get a green possibility. Again, we could have drawn 10 different branches, 7 of them labeled purple and 3 of them labeled green. But I'm just going to remember to kind of make my trees small because I'm going to prune them a little bit. And I want to combine all my purples together and all my greens together. And what I'm going to do with this tree diagram is I'm going to put probabilities in at each step. Okay, so here I drew a ball. The probability that it was purple for this first ball was our 7 out of 10. Okay, and the probability that it was green is 3 out of 10. All right, so now what we've done is we've drawn this first ball. And this problem, we are not putting the ball back in, although you could do this problem again with putting it back in. It would still look similar, and we'll talk about the differences in this next stage. So here I am, I'm up here. So I've gone this path, which means my first ball was a purple. So I'm gonna go back into my box. So here I am. And again, we could now have 9 different choices because there are 9 different balls left. But again, we're going to trim our tree, condense some of those pieces together as much as we can. And we're either going to get another purple or we're going to get a green. Probabilities here, now remembering we did it without replacement. We didn't stick the ball back in. We already got 1 purple. That means there are 6 purple ones left in our box and only 9 balls left in our box. And I will reduce this a little bit just to make numbers a little easier later on. Here I have a green. Again, there are 3 green ones, so there are 3 out of my 9 that are remaining. That's 1/3. Okay, some things to kind of keep track of, because we do know that probabilities do add up to 1. These guys added to 1. These guys will also add to 1. Because once you're here, it's like doing a whole nother experiment all over again. And again, either you're going to get the purple or the green. So these guys should add to 1 for you. Okay, I'm going to give myself a little bit of space. And I'm going to go down to here. So I kind of done because I've drawn my second ball. So this would be the first ball. Here's my second ball. So it's kind of like the second stage of that experiment. I'm going to go back so I can think of it if I'd gone this route instead. So here I'm down here at a green. Either I'm going to draw a purple or I'm going to draw a green. And if I drew a purple, there were, now think about it, this time we got a green the first time. So all 7 purple balls are still sitting in there. So that's 7 out of 9. 7 out of 9 does not reduce. And our green, well, we got a green here, so we no longer have 3, but 2 greens out of the 9 total balls left. Now, if we had done replacement, this 7/10 and 3/10 would have remained the same because we would have had the 7 out of the 10 still and the 3 out of the 10 because we'd put that first purple ball back. All right, we're going to calculate some probabilities. And the first probability that I'm going to do is we're going to find the following probabilities using some of the stuff we've already talked about or you already might have seen on my other video with just conditional probabilities. Find the following probabilities. So we are going to find the probability of getting a purple and a purple ball. So getting a purple on the first and a purple on the second. Sorry for my notation. But yeah, purple and then another purple. And that's basically going along this branch. So we kind of see that purple and purple. Now, this goes to our general multiplication rule that to get purple on the first and a purple on the second, we calculate the probability of purple on the first and then multiply it by getting a purple on the second given the purple on the first. So times that 6 out of 9, or I should have written that as my 2/3, sorry. Which is going to give me that 7 out of 15. Okay, let's calculate the probability of let's do, how about a green purple? So when I write GP, that means a green on the first, purple on the second. Okay, so that means I'm green on the first, purple on the second. I'm going to kind of write this here. Here's my 7 out of 15. So I'm kind of looking for this branch right here. Okay, so the probability that we got a green on the first, which is our 3 out of 10, multiplying it by the probability we get that purple on the second, given the green on the first, that's that 7 out of 9, which if I multiply those together, gives me 7 out of 30. Doing a little bit of reducing as I go. Okay, so I'll put that guy here too. We can also do the following pieces for the other 4 branches. So basically, this is our purple-purple situation, our purple-green. We would be multiplying these guys. That would be a 7 out of a 30. Here's my green-purple. And this would be my green-green, which is going to be 1 out of 15. Okay. One thing you'll also notice, these are the only 4 options that we have. So if I add these 4 up, I will get the number 1 because all of our probabilities for our total outcomes do have to add up to 1. All right, so I'm going to do a couple other pieces and see how we can figure this out. So let's say I want to find the probability that I got just a purple on the second draw. Oh boy. Well, purple on the second draw, well, that happened here. I'm going to kind of star it, put it there. I'm going to zoom out a little bit so we can see, hopefully. Kind of got some glare going on in here. There we go. Maybe that helps a little bit, maybe not. There, that helps a little bit. Okay, so we've got that purple on the second. Here's another one that's purple on the second. And now you have to remember that these objects are all completely disjoint. They do not have any overlap. So that means I can calculate the total probability by adding those 2 together. plus 7 out of 30, which would be, if I can do this in my head, because to add fractions, we need that common denominator, or grab our calculator to help us, or go to decimals. I like to stay with fractions just to force the issue of fractions. But this would be 14, so 21 out of 30, which does reduce. I'm just going to double check with my calculator. So I have 7 out of 10. All right. So there we go. Okay, some other things that we kind of want to make sure we remember. The probability of getting a purple on the first. Okay, I could go back here. These are my 2, the purple on the first. So I would be adding my 7 out of 15 plus my 7 out of 30, which is exactly what the numbers I had before here, which would give me that 7 out of 10. But also that probability is sitting right there. So because it doesn't matter what happens after, I just want to know what's the probability of getting a purple on that first ball. Well, that's going to be my 7 out of 10. So sometimes don't try to overthink these situations. Kind of back up a little bit, look at what's going on, and see if you can figure out the big picture. Similarly to this one, if I want to know probability of, let's do green on the second draw, given purple on the first. Okay, green on the second, given the purple on the first. Well, that means I'm on this track already, so that's happened. So the probability that my green is the second draw given the purple, that's my 3 out of the 9. So these probabilities that are sitting in here are conditional probabilities based on the happening of the first draw. Okay, things get a little bit weird if we start doing other things. So let's do a different, same problem, keeping my tree on here. So I want to keep my tree, but I'm going to cover up those pieces so that I can keep my tree, but ask different questions. So let's say I want to do, before I get to the hard one, let's just do one more kind of not as difficult. But I want to find the probability that both balls were the same color. Okay, both balls were the same color. That means a purple purple or a green green. So purple purple or my green green. Putting little circles there so I know. And again, these things are disjoint, so we can simply add those probabilities together. So that 7 out of 15 added to our 1 out of 15, which gives me 8 out of 15. Okay. Sometimes I kind of think to myself, if I hear myself saying the word and, I will think multiplication. So here I'm doing a purple and a purple. Notice we multiplied across the branch to get that 7 out of 15. A green green, I multiplied across the branch to get that. If I hear myself saying the word or, that means kind of adding. We have to be a little bit careful if these things are not disjoint. Then we have to go back to subtracting off that intersection. Otherwise, we count it twice. But if I see my or, I'm thinking adding. And these are disjoint because I have them all listed. So that's that purple purple or the green green. my purple, purple, or the green, green, giving me that 8 out of 15. Okay, these trees also come in handy trying to work with conditional probabilities. And I'm just going to do one example because they are a little complicated. We've done one more straightforward conditional probability. These guys were all conditional probabilities conditioned on what had happened the first draw. But if you start thinking backwards, it gets a little bit different. But I kind of want to remind us how we think through conditional probabilities or using that conditional probability formula. So let's do this example. So let's find the probability that we got a green on the first. Given we had a purple on the second. Okay, green on the first draw, given the purple on the second. And I'm going to go through the formula first. I'm going to remind us what that formula is, and then we'll go through it using our tree here. And then I'm also going to explain it in how we think conditional reduces our sample space. So reminder, if you have the probability of E given F, so this is the formula for conditional probabilities, it's going to be that probability of E and F, or E intersected with F, divided by the probability of F, so that given piece. Okay, so how does that translate to what we have? Well, the first top number is going to be our AND statement. So that means we are looking for the probability that it is green on the first and purple on the second. Okay, so that's our AND statement, or the intersection statement. And we're going to divide that by the given. Well, our given was purple on the second. Probability purple on second. Okay. The probability of green on the first and purple on the second, that's our green purple branch. That's that 7 out of 30 that we had calculated before. That's our green purple, because we had a green on the first and a purple on the second. That one right there. The purple on the second, and we've already kind of done this one, that was this starred piece or that starred piece. So we had to add those two guys together. So I'm going to kind of write them again. This was our purple purple or our green purple. Slide this up here for us, which was our 7 out of 30. Okay, just kind of going back to reminding myself the purple on the second, we did that one. That was right here, which reduced down to 7 out of 10. Saving myself a little bit of time. Okay, I'm going to take that 7 out of 30 and divide it by my 7 out of 10. 7 out of 30 divided by my 7 out of 10. So I'm inverting and multiplying if I'm doing it by hand, or I'm doing it on the calculator with my fraction button. I get 1/3. That is the probability of getting a green the first time, given that you know the second ball was purple. Kind of weird. Okay, to think about how that happened with the restrictions, thinking about how that conditional probability restricts our sample space. So I want to know, what is the probability of a green on the first given the purple on the second? So basically, I'm just looking at this branch and this branch. So I'm throwing these two away because they're not important to this problem, because I already know I got a purple on the second round. So out of these two, and to combine mutually exclusive events, we have to add their probabilities. So we'd add those two on the bottom. So out of those, adding them on the bottom. So there's my adding them on the bottom. I want green on the first. That's the one I was looking for. So that's why that is my top number. So 7 out of the 30, and dividing it by the addition of those two pieces together. Hopefully this helps a little bit understanding that conditional probability. Also, how we can use tree diagrams to help us out. If you had drawn the huge bush that we had talked about events at the beginning without trimming them, or pruning as I called it, and you had 10 branches here, and then you'd have 9 off of each of those, that would have given me 90 different possibilities, which is a lot. Okay, and 42 of those, I'm just taking the 7 times the 6, 42 of them would have been this PP situation. So we could have talked about how many we would have had, except using the probabilities, it gets a little bit easier when we have branches that all look the same. So again, I'm going to do one more example in another video. Please look forward to that. I hope you join me and look at it. I will see you in the videos.